Servo motor, diagram, definition, types, working and applications. What is a servo motor? A servo motor is defined as a linear or rotary type of actuator that provides fast precision position control for closed-loop position control applications. As compared to large industrial electric motors, servo motors are not useful for continuous energy conversion. These motors have a high speed response due to how inertia and are designed with small diameters, long rotor lengths. Servo motors have a mechanism that uses position feedback to control the speed and final position of the motor. Internally, a servo motor combines a motor, feedback circuit, controller, and another electronic circuit. These types of motors are best suited for smaller applications. With the advancement of microprocessors and power transistors, AC servo motors are used more often due to their high accuracy control. Construction of servo motor. It uses an encoder or speed sensor to provide speed feedback and position. The error signal available at the output of the error detector is not enough to drive the motor. So the error detector followed by a servo amplifier raises the voltage and power level of the error signal and then turns the shaft of the motor to the desired position. Essentially, servo motors are divided into AC and DC servo motors based on the supply used for their operation. Brushed permanent magnet servo motors are used for simple applications due to their low cost, efficiency, and simplicity of working. Parts of servo motor. Number 1 housing. Number 2 motor shaft. Number 3 bearings. Number 4 rotor. Number 5 stator. Number 6 brake. Number 7 snap ring. Number 8 O-ring. Number 9 bearing keeper. Number 10 encoder. Servo motor working principle. The servo motor works on the principle of the pulse width modulation method. In this, the angle of rotation is controlled by the duration of the applied pulse to its control pin. Essentially, the servo motor is a type of DC motor controlled by a variable resistor, potentiometer, and some gears. Working of servo motor. A DC servo motor consists of a DC motor, a position sensing device, a gear assembly, and a control circuit. The DC servo motor has a small DC motor is employed for driving the loads at a precise speed and position. This voltage is applied using a potentiometer by controlling the pulse width to the voltage converter or via a timer depending on the control circuitry. The dial on the potentiometer generates a related voltage which is then applied to the error amplifier. Through this converter, the capacitor begins to charge at a constant rate when the pulse is high. Then the charge on the capacitor is fed to the buffer amplifier when the pulse is low, and this charge is further applied to the error amplifier. So the length of the pulse decides the voltage applied at the error amplifier, the desired voltage to produce the desired speed or position. The feedback signal corresponding to the present position of the load is obtained by using a position sensor. This sensor is normally a potentiometer that produces the voltage corresponding to the absolute angle of the motor shaft through the gear mechanism. Servo motor mechanism. A servo system mainly consists of 3 basic components: a control device, an output sensor, and a feedback system. This is an automatically closed-loop control system. Here, instead of controlling a device by applying a variable input signal, the device is controlled by a feedback signal generated by comparing the output signal and reference input signal. Advantages of servo motor. It has high efficiency and can reach 90% at light loads. The motor provides high torque to inertia ratio and can accelerate loads rapidly. Disadvantages of servo motor. The drawback of the servo motor is that it demands tuning to stabilize the feedback loop. If something breaks, the motor will be unreliable. Therefore, a protection circuit is required. The overall system cost and installation cost are higher than that of a stepper motor due to the need for feedback components. Applications of servo motor. The servo motor is used in robotics to activate movements, giving the arm its precise angle. These are used to start, move, and stop conveyor belts carrying the product along with many stages. For instance, product labeling, bottling, and packaging. The servo motor is built into the camera to correct the lens of the camera to improve out-of-focus images. This motor is used in a robotic vehicle to control the robot wheels, producing plenty of torque to move, start and stop the vehicle and control its speed. Conclusion. In short, servo motors are used in many industries and have many advantages as we discussed above. They offer many solutions regarding mechanical concerns and have features that make them powerful and efficient. Thanks for watching.